Okay, let's try this question. They say that ABC is tangent. This line here, ABC, AC here is tangent to the circle right there at B, and BE is parallel to CD. That's given. You're supposed to prove that D1 is equal to C. Well, I see these parallel lines, and parallel lines, I'm supposed to use C. Hey, B1 is connected to C, and B1 is connected to D1. I can see that's tan chord, and I can see that's corresponding angles. And that's how you do it. B1 is equal to D1 because of tan chord theorem. B1 is equal to C because corresponding angles. And therefore, D1 equals C. Therefore, D1 must be equal to C because they're both equal to B1, so they must be equal to each other. Okay, the next question, and you don't have to give a reason there. I'd like to, but you don't have to. Now, ABCD is a cyclic quadrilateral. Okay, so we've got a cyclic quadrilateral. Well, we're told that this bisects these two things here, where these two angles are equal. And we're supposed to prove that DC is equal to DB. You know, there's more than one way to do this question, and when I was thinking of the strategy, I did it this other one 6 months ago, and I thought of a strategy using this angle here, A1 equaling this C1 and C2 together. Well, that was the same. But then you can use angles in the same segment to get at this thing of DC equaling DB, but you don't have to. So let's just do the first thing. A1 is equal to C because of the exterior angle of a cyclic quad. We're given that A1 is equal to A2 because AD bisects it. Well, that's true. Well, that means that A2 here has to equal this big angle C. But angles in a circle that have to open up, if the angles are equal, they have to open up to the same size of chord. Therefore, DC equals DB because of equal angles make equal chords. Because we've got equal angles, they must make equal chords. You see the angle C, that means DB here has to equal DC. And that wasn't such a bad way. That's how I did it back then. I did it different when I was just thinking about it, what to do, but there you go.